Well, welcome to Spokane Community College. This is the Automotive Machinist program. My name is Butch Reilly, and what we're going to do today is work on reconditioning these connecting rods. The first thing that I want to do is go through the process of dressing the stone on this cap cutter. You might want to notice that the diamond in this little fixture is actually setting in there at an angle. Periodically, I'll take this set screw, loosen it, and I'll rotate the diamond a quarter of a turn. What that does is the dressing process of the stone will keep the diamond sharp. What I hope you notice there is I actually move the diamond across the stone in a rather quick motion. What I'm trying to do is to rough up the stone, make it coarse, so it removes the material from the connecting rod. What happens is we grind material off of the connecting rod and the connecting rod cap. The material from the two items will clog up this stone. You're going to notice that after you've done a set or two or three connecting rods. As you machine the next ones, the stone's going to start squealing and squeaking. That tells you that it needs to be dressed. What I've done is I've prepared a couple of connecting rods and a couple of connecting rod caps. And what I need to do now is to show you what I did to prepare them. First of all, the connecting rods have been completely disassembled. The rod bolts have been removed. The connecting rods have been cleaned. We've actually magnafluxed these connecting rods to make sure there weren't any surface flaws in them. We've got a stone here that I like to use to rub the connecting rod over, and I'll do that to the cheek surface, and I'll do it to the parting edge. Because what I'm going to end up doing is I'm going to put the connecting rod in the fixture, and this face plate, I want to make sure there's no burrs or high spots on the connecting rod cheek. I also want to make sure that the portion that I'm going to machine, the parting edge here, is setting flat on the fixture so I know the amount of material I'm removing. So I'm going to just do that to a couple of rod and a couple of caps. What I'm going to do now is I'm going to take the connecting rod and I'm going to set it in the fixture. I'm going to lower the stone, and now what I'm going to do is raise the stone up just so it touches the connecting rod. At that point, I can look through this gun sight and I can raise this up 2 thousandths. Okay, turn on the electric motor. Okay, now you can see on the connecting rod here how nice and smooth that's machined. And what I'm going to continue to do now is take 2 thousandths off of each of the connecting rods and also off of the connecting rod caps before we put them back together and actually start our honing process. You may have noticed that once I set the height of the stone with that first connecting rod that I machined, I didn't touch the height of the stone anymore. What that accomplished when I initially set that is the height of this stone, this grinding wheel, was set 2 thousandths above this bar. And this is what we're setting all of the parts on in order to machine them. Now, I get in the habit of putting the connecting rods in, and I notice where the locating lug for the rod bearing goes. and I position all the connecting rods that way. Just my preference is now when I go to do the connecting rod caps, I'm going to position the caps the opposite direction. And here I don't need to raise or lower the stone. It should be all set so I can machine 2/1000ths off of the caps. Another thing I want you to notice, after I've finished machining the parting edges, I do not set that new machined fresh surface on the bench. I want to protect that. The other thing that you might have noticed is the speed that I moved the connecting rod or the cap across the stone was slower than when I dressed the stone. When I dressed the stone, I went quickly to make the stone coarse, to clean out all the pores and expose new grit. But now when I went to machine the cap or the connecting rod, I moved it slower because I can actually adjust the surface finish here, RA if you want, and have that very smooth. Or if I moved it quickly across, I would end up having a rather coarse finish. Personally, I like to have the smooth finish. Okay, now what we're going to do is we're going to take each one of these caps and each one of these connecting rods, and I'm going to break this sharp edge where it leads into the housing bore. I know that all of you that have assembled engines before, when you put the connecting rod bearing in the cap or in the connecting rod, that last 1/8 of an inch that you slide the bearing in, sometimes it just skins a little bit of the bearing off, the bearing backing. By breaking that sharp edge, that's going to cure that problem for you. It is a little more time consuming, but personally I think it's worth the extra time spent. So we're going to grab the file here, move to this soft jawed vise, and we're going to chamfer the edges of these, just a very minor amount. This isn't something that's mandatory to do, but like I said earlier, those of you that have assembled engines, and when you go to slide the rod bearing in place, that last 1/8 inch or so to position the bearing in the housing bore, it seems like it might just scuff the back of the bearing a minor amount. This eliminates that problem happening, and I like to spend the time doing this because it might take an extra couple minutes for each set of connecting rods. Okay, after we finished filing the edges on all the connecting rods, I'm going to do the same thing to the rod caps. Okay, now what we're going to do is I'm going to turn to this other table in our little arbor press, and we're going to go reinstall the connecting rod bolts back into the connecting rods. First I'm going to blow out the bolt holes. Might be a little bit of dust from the grinding process left there. And you may have noticed right now that so far I haven't worried about keeping the connecting rods in order. The connecting rods and the caps are all numbered. That's the first step when you disassemble an engine, either to number them or to make sure they're numbered from the factory already. Now what I'm going to do is take some connecting rod bolts and we're going to install them in the connecting rods. What we have is this arbor press and a little tube. We'll adjust the height here. The caution that I want to give you on using this press is make sure that the plunger, this portion, is off to the edge of that bolt head so it doesn't come down and scar the connecting rod beam. I like to be very cautious about the connecting rod beam. That's a good place for us to start a surface flaw that may end up into a crack in the rod breaking. Okay, now that we've got all of the connecting rod bolts in the connecting rods, I'm going to lay the connecting rods out here in order, 1 through 8. And then I'm going to grab the rod caps from the opposite bench, and we're going to set those up right next to the rod bolts. Okay, now we're going to go ahead and assemble the rods and caps. On most of today's connecting rods, the locating lug for the rod bearing goes on the same side, as well as the numbers matching up. Okay, we're going to oil the rod bolt threads. Now all I'm doing is starting the rod nuts onto the rod bolts, and then I'll actually run them in with a 3/8 drive air wrench. Then we'll move on to actually torquing the rod bolts. Now what we're going to do is torque the connecting rods and caps in place. This is a special vise, and what it's going to allow us to do is to line up the connecting rods and caps this direction. Smooth jaws here, and it's simply a T-handle where we tighten the the jaws against the connecting rod. So the clamp effect positions the connecting rods this way to their caps. Also notice that I've got the pin end of the connecting rod split here. On a lot of connecting rods, the pin end of the connecting rod is wider than the big end, the journal end. And for that matter, or for that reason, I always split them when I set them in here, so I don't put any stress on the connecting rod, maybe causing a bend. We've already looked in the specification manual, and the torque for these connecting rod bolts is 45 pounds. So I'm going to set the torque wrench at that poundage, 45, and we'll go ahead and do these. Make sure that when you put the connecting rods in the vise that you have the clamp portion right across the parting edge. Okay, now that we've got the rods machined, retorqued, we're going to move over to the honing machine, and now we're going to restore this housing bore to its original diameter. What I want to show you right now is how we would check these 3 gauge points to make sure they're measuring a perfect diameter. This top finger is adjustable, and what we can use is a perfect circle to set over the gauge points, and we can adjust this top point up or down so it reads directly across the diameter. In this small box, we actually have 2 of these perfect circles, and the one that we're going to use first is this larger ring. I'm going to take the spin type. We're going to be able to slide it through this slot in the perfect circle and be able to adjust this ring. So the first thing I'm going to do is loosen up the clamp. I'm going to set the perfect circle over it, and you can see it's a little, the gauge points are too large. So I'm going to shrink this down so I can put the circle over the gauge points, and now I'm simply going to expand the gauge points so I get a reading on this dial indicator. The next thing I'm going to do is take this spin type and I'm going to slide it up through the slot, and this is actually an Allen wrench, that top gauge point. And what I'm going to do is I'm going to turn the gauge point, and I want to get its largest reading on the dial indicator, and it happens to be right there. We had this set just fine. So this was set. Okay, at this point I want to set the gauge on the machine so I have a way of comparing when we get to the proper size. I'm going to take an outside micrometer. We've already looked up the specification, and what I need to do is set this micrometer at 2 inches, 225 thousandths. And I'm going to lock this in position, and now what I'm going to do is hold the micrometer against these two gauge points. I'm going to loosen the lock, and as I expand, or as I turn this lever counterclockwise, you can notice that this top finger kind of travels at an angle, and then this bottom finger travels directly out to the side. These move equal. And we're going to expand these fingers until the needle on the sounding gauge reaches the 3 o'clock position if this were an analog clock. So I don't get real carried away that it's exactly at 0. What I'm going to do now is I'm going to use my thumb and my small finger, and I'm going to have those help me position the micrometer right over those gauge points. Oh, that was pretty lucky. We had it set virtually at 0. And then I'm going to lock the bezel clamp so that doesn't move. At this point now, the gauge will tell me how much smaller than 2 inches, 225 thousandths the connecting rods really are. At this point, I'm going to take each connecting rod, I'm going to set it over the gauge. This one tells me I have about 3.5 thousandths to come out of. And what I'm going to do is match these up in pairs. Because eventually what we're going to be doing is honing 2 connecting rods at a time. Okay. So I've paired up these connecting rods. I want to talk a little bit about the mandrel we're going to be using in order to hone these housing bores back to the factory tolerance. I'm going to use this T-handle, loosen up the clamp, and at that point I can remove the honing mandrel from the machine. We have different size honing mandrels. This one is numbered 2100. But the important thing for the operator to recognize is we have written right here over 2.200, and on this side we have under 2.200. The housing bore of these connecting rods is 2 inches or 2.225. In other words, it's over 2.220. So what I want to do is I want to rotate this eccentric, and hopefully you can see where this is thicker and this is thinner. And I can rotate this around from one side to the other. For example, right now it's showing here under, the arrows at under 2.200 thousandths are lined up. Well, what we have is over 2.200 thousandths, so I'm going to rotate the eccentric. So now we have over 2.200 thousandths. To install the mandrel in the machine,